In this video, we're going to have a look at adding and subtracting expressions that contain surds. To add and subtract expressions that contain surds, the first step is to make sure that each surd in the expression has been written in its simplest form. If it's not in the simplest form, then you need to go ahead and to simplify it. Then the second step, once it's all been simplified, is to add and subtract any numbers in front of surds that have the same square root number. So let's go and have a look at a couple of examples. So in the first example, I want to simplify 7 square root of 2 minus 3 square root of 2. Now if I have a look at the numbers that I am square rooting, we can see that they're both the same and they're both in the simplest form. So to simplify the expression, I have a look at my numbers in front and either add or subtract them. In this case, it is going to be 7 minus 3, which is equal to 4. So 4 times the square root of 2. Similar to what we do when we're collecting like terms in algebra. In the next example, the expression is 9 times the square root of 3 plus 3 times the square root of 6, subtract 6 times the square root of 3 plus 2 times the square root of 6. So having a look at the numbers that I'm square rooting, I have the square root of 3 and the square root of 3 and the square root of 6 and the square root of 6. Now both of those numbers are already in the simplest form, so I can go ahead and add and subtract any numbers in front of my square roots that are the same. So having a look at the square root of 3, I've got a 9 minus a 6. So that is going to equal to 3 times the square root of 3. Then having a look at the square roots of 6, plus 3 plus 2. So that's going to be plus 5 times the square root of 6. So my simplified answer is 3 times the square root of 3 plus 5 times the square root of 6. The next expression that I want to simplify is 8 times the square root of 5, subtract the square root of 20. Now having a look at those numbers that I'm square rooting, 5 and 20. 5, it's already in its simplest form, but 20 is not. It can be simplified further. So having a look at the square root of 20, the factors of 20 that I can use are going to be 4 times 5, because I know 4 is a perfect square. So that is going to equal to the square root of 4 times 5, which is equal to the square root of 4 times the square root of 5, which is equal to 2 times the square root of 5. So now I can rewrite my original expression with my updated simplified value. So that's going to equal to 8 times the square root of 5, subtract 2 times the square root of 5. And so subtracting my numbers in front of my like surds, 8 minus 2 is 6. So the answer is going to be 6 times the square root of 5. Now having a look at my last example, 5 times the square root of 12 plus 4 times the square root of 27, subtract 3 times the square root of 15. So having a look at the numbers that are under my square root symbol, 12, 27 and 15. 15 is already in its simplest form, but 12 and 27 can be further simplified. So 5 times the square root of 12, and the factors I'm going to use are 4 times 3, because 4 is the perfect square. So it's going to equal to 5 times the square root of 4 times 3, which is equal to 5 times the square root of 4 times the square root of 3. So 5 times 2 times the square root of 3 equals 10 times the square root of 3. And for the second, 4 times the square root of 27, the factors I'm going to use is 3 times 9, because 9 is the perfect square. So that's going to equal to 4 times the square root of 9 times 3 equals 4 times the square root of 9 times the square root of 3 equals 4 times 3 times the square root of 3 equals 12 times the square root of 3. So now that I have gone ahead and simplified, I can rewrite my original equation. And it's going to be 10 times the square root of 3 plus 12 times the square root of 3 minus 3 times the square root of 15. Looking for the square roots that are the same, and then adding or subtracting those numbers together. So 10 plus 12 is 22 times the square root of 3, subtract 3 times the square root of 15. And that is my simplified answer. So there are 4 examples of how we can add and subtract expressions involving surds.